A couple of hours ago, I turned 26. Now I'm headed up to the robotics building in the middle of the night. Why? The life of a grad student. I've got experiments to run and a thesis to complete. But that's not the only thing I'm doing on North Campus. Hi, I'm Will, and pretty soon you'll know which Will, and you and I are going to meet face to face. As we wind down on the anonymity for the next few weeks, let's get back to the technology of it all. I've been super busy with my dissertation, but I've still managed to cook up some exciting science and tech to entertain and astonish. And like any good comic book character, I'm ready to use myself as a guinea pig in the most dangerous way possible. We've been hearing a lot about sentience in the age of artificial intelligence. Are LLMs, that is, large language models like ChatGPT and DeepSeek, sentient? If you've been wondering this, you might be asking the wrong question. Sentience, the ability to feel, perceive, or experience subjectively, is different from sapience, the capacity for wisdom, knowledge, and understanding. It is why we as a species gave ourselves the name Homo sapiens. It means wise gay man. Just kidding. It just means wise man, literally the epitome of this meme. Both sapience and sentience are certainly sought-after attributes for AI, but the distinction is important, and most people might be more interested in sapience when it comes to large language models. And if you want my professional opinion, LLMs are not sentient. They absolutely do not have the ability to feel, perceive, or experience subjectively. But you can ask them to pretend that they do. Okay, so I'm here in ChatGPT, and I'm going to give it a situation where it has to pretend to be sentient. Pretend you've just been rejected by your crush. You're my bro and seeking comfort from me. You're kinda toxic and pretty upset about it, but you're a good guy deep down and just need some guidance, and you need to be talked down a bit. Okay, so we got the two responses. Oh my gosh. Okay, we're going with this one.
Bro, she curved me, like full-on, Olympic-level dodge. I poured my heart out, genuinely. And she hit me with that, "You're such a good friend" speech, like I didn't just open up my soul. Man, I feel played. Like, what was all that? The late-night combos, the way she laughed at all my jokes, even the bad ones, the deep talks. That wasn't just friend energy. Come on, I'm not stupid.
Nah, friends can be like that, bro. And see, I'm even falling for it.
And don't even get me started on her new thing. Dude looks like if wallpaper came to life.
Her new thing? Dang, that's crazy.
No personality, no vibe, just there. And she chose him over me? Me? Bro, I've been there. Loyal, listening, hyping her up. And for what? To be emotionally benched? I'm so close to deleting her number, blocking her on everything, and pretending like she never existed. I won't. But damn, I want to.
That's like, honestly, that's pretty tame. Like, you probably should do that.
I don't get it. I tried to be a good guy. I was real with her. And now I'm just a sweet friend. I feel like such a clown, man. Please tell me something before I go full villain on. I need you right now, bro.
Okay, he needs me. I've got to help out. Let's see. I got to be compassionate. Dude, I am so sorry. I know how much she meant to you. And yeah, this really sucks. You were a really good friend, and that's extremely honorable, and I respect you for that. I know you're upset, and I'm gonna give you grace to deal with this, but this crash out, it's not like you, man. You're a lover, not a fighter. She just wasn't the one. If she rejected you, was never right for you. Okay, gotta finish this up with something. I'm here for you, man, and you'll find the right girl. I just noticed this AI just assumed that they were straight. It's pretty funny. I mean, I guess it's like, statistically, it's a fair assumption, but just funny, like I didn't mention a gender up here. That's pretty funny. All right, let's see what it says. ChatGPT is famous for gassing up their users in really stupid ways. All right, he said,
Damn, bro, you got me with that. I'm not even gonna lie. I felt that in my chest. Like you just threw me a life vest while I was drowning in my own ego and heartbreak. You're right. You are. I'm just in my feelings right now. And when I get like this, I spiral. I start acting like I don't know who I am. But I do. I'm not some bitter dude out here plotting revenge or throwing shade. I just cared too much. And yeah, it hurts like hell when that doesn't get returned. But hearing you say that I'm a lover, not a fighter, that hit. Because I've been that guy. I am that guy. And just because she couldn't see it doesn't mean someone else won't. She wasn't the one. That's facts.
That's facts. No way.
If she couldn't match the energy I brought, then maybe it's a blessing she dipped now instead of later when I would have been in deep.
No, that's wisdom right there. Take that, all you boys out there and girls, take that right there. It's a blessing she dipped now instead of later when you would have been in deep.
Thanks for being solid, man. A lot of people talk about loyalty, but you show it. I needed that anchor. I'm still hurting, but I feel a little bit more like me again. Let's get out of here. Get some food or something. I need to be around real ones.
Okay, so this is perfect. I cannot believe how perfect this example is. So you might be enticed by this interaction because it feels real. Like I feel like I just helped my guy out. And the oohs and ahs of tech bros were heard everywhere. But this is, of course, a flat out objective lie from a straight up logical standpoint. And if AI can lie about this, it can lie about everything. No, these algorithms don't have experiences. They have no receptors, no touch, sight, taste, smell, or hearing. It's not the only requirement for sentience, but a vital component is perception. It's literally in the definition. Receptors, or sensors, as they are commonly referred to in artificial beings, will thus never go out of style. Sentience and sensor literally come from the same Latin sentire, meaning to feel. Cameras, tactile sensors, tilt sensors, microphones, the optimization of these devices is key to creating sentient AI. If that's your thing, I mean, it's not really my thing. I mean, I'm not afraid of it or anything. It's just way cooler to enhance human beings. No, this is all to say, sensors are pretty important, guys. And today, I'm going to be making some pretty creative sensors, if I say so myself. But first, holy shit, I need to clean up. There, that's better. Now, sensors are vital to making the things I want to make function properly. But first, did you know we have more than just 5 senses? My personal favorite is the vestibular sense inside your inner ear. This allows for us to have some sense of our orientation in 3D space, as well as acceleration feedback that allows us to balance in the presence of disturbances. It's the thing that lets me do this, and I'm forever grateful. What's cool about the vestibular sense is it consists of fluid moving through canals, brushing up against tiny hair cells on your cupula. So it's actually a big sensor comprised of little sensors. And this provides us with some much-needed engineering inspiration. We can be super creative with hardware design to turn simple sensors into something designed to understand something more complex about the world. Let's start out with something awesome. You all remember this. This wasn't even this device's final form. I'm all about ease of use. The original vision for this device was automated loading and unloading of tensile line into the 2 reels worn on the upper arm. One reel pulls the rope and the other one releases. It is, in my experience, painful to try to make this happen in a feed-forward manner. And after months of fine-tuning, I got nowhere. So we're going to use closed-loop control or feedback control. But that means we need a sensor. Now, the last time I used this thing was actually in October, and I did this sort of scary test where I was trying to hang upside down. I couldn't really hang upside down, but regardless, this was with this version of the device, and this is actually the first time I tested the device without needing to replace components after the test. That is due to the intense iteration I've put into this device here. The first idea I had for some kind of sensor that could provide feedback and match the speeds of these two rotors up a little bit better was an encoder. And this was one of the many great suggestions by the commenters on my original video. And it's the one that I was planning on doing for a long time. But after thinking about it for obviously quite a while, I realized that it's not the best solution out there. Basically how this idea would work is if we have this reel here and this reel here, and we wind this around our attachment point, push it through this tensioner on the other reel, and want to have it stick to this reel's rotor so that it can be wound there. So that is winding it around the attachment point here, so that the rope needs to travel off of this reel and onto this reel. This is the velocity of the rope. Basically how I originally envisioned this working is on the reel that's winding, on the reel that's pulling in, you have a little wheel system here. So two wheels that are pressing on either side of the rope. And so they have sufficient static friction at the point of contact. And obviously, so these reels are spinning. On one of them, you mount an encoder that will give you the digital signals that will tell you what the velocity of this rope is. Then you have some feedback system to give a velocity command on this motor. Let's call it U. So this control system essentially becomes U is a function C of V. This is our feedback control. There's a severe problem with this, right? Let's say this system gets into a state where the rope gets stuck somehow. Let's say it randomly torques out on the winding in such that the velocity of the motor goes to 0. Assuming that C is a linear control law, then U is also going to go to 0. So if this rope were to get stuck for any reason, the whole system would just completely stop. Now that's not actually what we want. Instead of a control law based on velocity, we would like a control law based on tension in the rope. Let's put it this way. Two issues can happen with this reel. For the first case, this reel is not pulling in while this one is releasing. Or two, this reel is pulling in while this one is not releasing. Those are the two possible problems. Now, either way, the velocity of this rope is going to be 0. The rope's not going to move if either of these things happen. So how do we differentiate between these two cases? Well, in case 1, when this reel is pulling in and this reel is not releasing, there is tension in the rope. Let's call the tension force T. In case 1, the rope is not being pulled on, so we have the tension in the rope equaling 0. In case 2, the rope is being pulled on, so we have a non-zero tension. If this motor gets commanded a velocity of U1 and this motor gets commanded a velocity of U2, we can imagine a control law whereby we have no tension in the rope, then we need to have U1 go above 0 and U2 go to 0. And if we have tension in the rope, then we need to have U2 go above 0, and U1 will have to do something. So you'll notice in both cases that U1, which is the speed of the pulling in motor, is greater than 0. So we can just set that equal to a constant U. Basically what this means is we can just change our control system to focus on a single reel, that is the reel that is letting out rope. So this rope is leaving this reel at a speed of V, and V is actually determined by the speed of the reel that is pulling in. And this reel is spinning to let the rope out with a speed of U2. The rope has tension T. So really all we want to be able to do is have this reel spin with non-zero velocity when there is non-zero tension. So we can have a very simple proportional control law where the speed of this reel is proportional to the tension T with some constant K.
You're not impressing my stream. Everyone knows you're using a calc. Calc is calculator for short, chat.
Now how are we going to sense the tension in this rope without interfering with the rope itself? Well, we can actually measure the restraining force on this reel and consider a force balance where F is equal to T. This F is the restraining force on the axis of this reel.
Now, of course, to do feedback control like this, we need some kind of force sensor that can sense the retaining force on the pulley. Now, my first iteration of this consisted of a thin piece of conductive rubber whose resistance would change depending on if it's being pushed on or not. Okay, so we have the bearing in here, and it looks like if we push on it, it's registering about 6 kiloohms. If we're not pushing on it, we're registering about 5.5 kiloohms. So it's not super sensitive. I don't think this is going to work. And I also wasn't sure about the durability of a system like this. The same goes for force-sensitive resistors. So I realized I could switch to the most durable and sensitive system possible. That just goes from 0 to 1, the limit switch. This way we're only sensing ones and zeros. Now, because this is a digital sensor, T is only going to be 0 or 1. So what might end up happening is, let's say this is T and this is U, starts with no tension, then it starts being pulled on. There's going to be some delay in the control system, so it's going to let out a little bit after there's tension on the rope. But as soon as it lets out, the tension on the rope drops. Then, because the other reel is going to keep pulling on it, the tension is going to rise again, and then after some delay it's going to let out because of the control law. And so what you see is we end up with some oscillation. And this will almost certainly happen with a system like this. And that's not good. So what we can actually do to mitigate this effect is actually modify our control law to consider a filter on the limit switch measurement. It's actually going to move up more slowly, and that means that in return this is also going to move up more slowly, and it's just going to basically get rid of any kind of high frequency oscillation that you might have from the nature of using a limit switch as a tension sensor. I realized after explaining all of this, because the reel is belt driven, I'd need the whole transmission, motor, belt, and reel to be mobile together. They'd all need to slide on a linear rail of some sort to contact the limit switch. At first, I didn't want to do this, as it seemed daunting from a design standpoint. I also tried using the ACS 712 current sensor to see if the motor torque was correlated to the rope tension, but I couldn't get a predictable reading. Another dead end. So I realized the mobile transmission was the way to go. This was a heavy hardware design, but I managed to keep the bulk to a minimum. One thing that helped me mitigate this was adding these really stiff and tiny springs mid-print, which I don't think I've ever seen before. Finally, the new reel, complete with tension sensing, was finished and ready to test.
All right, everything's coded up now. I just want to quick test these tension sensors. I just want to real quick test these tension sensors with the serial plotter here. It looks like that one's working, that one's working. So I've coded up. You can see they're smoother than discrete. So we get a filtered signal with the low pass filter. And I'm actually using both sensors together to measure tension as well. So we have another dimensionality there. And depending on which reel is to pull, that reel is getting weighted larger. So you can see that one's bigger and that one generates a smaller pulse. All right, so let's test out the controls.
All right, let's see if this made a difference. So, stick it into the other reel. What we're hoping for here is a far easier loading time. Okay, it's attached. Flip this on. Okay, that kind of worked, actually. That kind of worked. Okay, so then that hooks into the wrist unit, and then rappelling happens. Whee! And then, once we're on the ground, we switch back. Okay, this side is kind of having some trouble. It's outloading too fast. And the tension is not resetting. If I hold my arm upright. Hey, bro. You are not in tension. Relax. Okay, that came out. Just like it's supposed to. And then, now we're back on this reel. So that was actually the first time I've ever loaded it completely off this reel and then completely back on this reel, like in that short amount of time. I think that's pretty good. It's still not great. The issue is these, it's kind of hard to pull them down. But then also when they're in this position, once they're down, they kind of want to stay down because the weight of this carriage thing. I don't know if you can hear the clicking, but it's not super predictable and also not super sensitive. So I think the best thing is to develop this a little bit more. But I think it's definitely something that assists the process. So I think that's good. It definitely helps if I hold my arm a little bit more horizontal so these don't have to deal with gravity. Yeah. So I'm going to try that in the real world. Okay, so we're going to try it up there. Hope to make less than 2 minutes. You got to look the part.
I like an escalator, man, because an escalator can never break down. It can only become stairs.
I'm going to keep it $1.50. It took me about 3 minutes from the hooking in to the repelling.
All right. Oh, cool. Great.
Is it faster than before? Probably, yeah. But this device was supposed to be operated in mere seconds. I think I've reached the limit on this version of the system, and I've got to take what I've learned and apply it to version 2, which will hopefully be consumer-facing.
Let's see here. So I want to try a thing where I'm like swinging and then I like rappel down at the top of the swing. Let's see what that looks like. Hey, that was cool. Okay. Oh, that's cool.
Now, the other sensor I'm going to be prototyping today is the wearable force myography grid I talked about in this video. You can check that out by clicking the card up there somewhere. Basically, it's an alternative to EMG using these tiny force sensing resistors. It's going to be a key component to the miniaturization of my spray bracelet, or spracelet. Keep suggesting alternative names in the comments, please. Now, I'm trying to build a business here, so it's not enough to just make an FMG wristband and test it out. I need to come up with an efficient manufacturing method so I can keep costs down. Additive manufacturing is a great way to do this at low volume and since this sensor needs to be a flexible wristband, I'm going to use one of my favorite materials, soft TPU, with a shore hardness of 85A. This material has been key to the legs of Charlotte, my 8-legged robot, but also to the symbol light, a flexible lighting fixture you can fit under any garment. You can buy your own custom symbol light at dragline.tech, garment not included. Here's a few that I've made for customers thus far. Shout out to Spider610, a longtime viewer, for purchasing his symbol, the one you see here. Symbol light comes with a handy 9-volt connector and switch, all made of this soft TPU material. Get yours today at dragline.tech. So back to using TPU for FMG construction. I came up with this layered design, which allows me to add not only the FSRs, but the resistors and the wiring in a neat and tidy way.
First of all, we've got the power line, so we're going to clean it with alcohol and then place it to be printed over with TPU.
Some soldering is still required, but not much. Now that I hopefully have a working bracelet sensor, I can hook it up to this analog multiplexer so I can access all 10 sensors from a single microcontroller pin. The microcontroller I'm using is my custom MCU, tailor-made for bracelet miniaturization and manufactured by this video's sponsor, PCBWay. PCBWay provides incredible PCB manufacturing services. I've done both a whole mount PCB, which I self-assembled, and this turnkey surface mount board, and both boards had me completely gagged with the quality of the craftsmanship. I also used their machining services to make an updated version of my bracelet pressure vessel, and now it's time for me to do that yet again, as we are miniaturizing further still.
Okay, here we have our new design for a slightly smaller, more compact pressure vessel that fits our custom PCB board quite nicely. So this is for further miniaturization of this bracelet. So all we have to do is export these two parts as step files. So this is our inlet side, and this is our outlet side. So now we have our parts here. And if we go to PCBaway.com, we're going to select a CNC or 3D printing quote. We're going to have one of each of these parts, and we want aluminum because it is lightweight and strong. And all we have to do is where it says drag and drop files, drag and drop these files. So we can select the material. We like aluminum 6061, silver white. Now for surface finish, we're going to try selecting the smooth machining. I like to do all the tapping myself. That's why I don't need to upload a drawing. It's great that drawing isn't required. So there's no inserts, no tighter tolerance required. We don't need any assembly. We're going to select the standard inspection, product description. We are going to count industrial metal components. So everything is the same, industrial metal components. Yeah, so it's that easy. You just basically drag and drop the parts, select everything you want to select, and yeah. So it's about $80 for both parts. So it's actually a little bit less expensive than the other ones, which makes sense because they're smaller. So we're going to submit this request, and I agree. And so now these parts are submitted. Perfect.
And just like that, I've got high-quality aluminum parts headed my way. PCBWay also provides 3D printing services. Check the link in the description below for $5 off your parts today.
Okay, so I've written up some code here, and we're gonna try to see if we can get some signals. So you can see we've got some signals that are kind of not consistent. So the base force that each of these are experiencing are quite different. So that seems to be not a predictable part of the manufacturing process, but it looks like for the most part, we've got all the sensors able to sense things, except for some of these guys, there seems to be like a bad connection. Which isn't great. I think 2 of these have a bad connection. These 2 right here. So we basically got 8 out of 10 sensors, which is still not terrible. We'll get better at the manufacturing process. And I think I will be able to do still researching my FMG machine learning algorithm with this wristband. And you can see they do some fun things like as you're twisting this around and that sort of thing, which is pretty cool. So let's see. If I keep this here, if I wrap it around, and you can see if I do some gesture recognition here, you can see the signals are changing in response to my gestures. So that's no movement, and now I'm moving my fingers and the signals are going crazy. So there is some instance. So this is fist, and then this is signal, fist, trigger, fist, trigger, fist, trigger. I think it's going to be able to tell the difference. See, some of these are moving quite a bit. So that's pretty promising. Wow. Now, there's obviously a lot of noise happening with this sensor. So we'll see about that. But right now, I'm really excited that this is working and this exists. And yeah, this is pretty cool. Looks like FMG development is finally in motion, but hardware is just half the battle. A machine learning algorithm will be the next piece of the puzzle to take these signals and turn them into commands for wearable devices. Tune in 2 weeks for the final anonymous episode of this channel. The hierarchy of power in the DC universe is about to change. Stay safe, stay amazing, and
I'll be seeing ya.